We'll solve a special relativity problem about a train accelerating from rest. Let's read the problem statement. Let's break down this problem step by step. We have a train of length 350 meters, starting from rest and accelerating at 3.0 times 10 to the negative 2 meters per second squared. At t equals 30 seconds, event 1 occurs. The headlight at the front of the train switches on. Let's calculate the train's position and velocity at this moment. The velocity at t equals 30 seconds is w times t, which gives us 0.9 meters per second. And the displacement from the start is 1/2 wt squared, which equals 13.5 meters. At t equals 90 seconds, event 2 occurs. The taillight at the rear switches on. Again, let's calculate the position and velocity for the train at this moment. The velocity at t equals 90 seconds is 2.7 meters per second, and the position of the front of the train is 121.5 meters. Since the tail light is at the rear end of the train, we need to subtract the train's length. So the rear position is 121.5 minus 350, which equals negative 228.5 meters. Now let's solve part A, finding the spatial separation of these two events in different reference frames. First, in the train frame. Since the train's length is constant in its own frame, the spatial separation between the headlight and tail light is simply the train's length, 350 meters. Second, in the earth frame. Here we need the difference between the position of event 1 and event 2. That's the absolute value of negative 228.5 minus 13.5, which equals 242 meters. Finally, for part B, we need to find the velocity v of a reference frame K, where both events occur at the same spatial location. For events to occur at the same place in a moving frame, that frame must move at the right speed to connect the events. We can calculate this speed as the spatial separation in the earth frame divided by the time separation between events. V equals 242 meters divided by 60 seconds, which equals approximately 4.03 meters per second.